So you guys need to show some respect when you get home to your families, okay? And show some respect to me when we're in school. And all will be well in the real world, okay? Let's go ahead and get started. We are doing Chapter 9, Lesson 6, Permutations. So our learning goal is that students will be able to find the number of permutations of a set of objects and find probabilities. Permutations is a mouthful, that's for sure. This is something completely new and different. I will say that the math portion of permutations is very easy. So, once you figure out the word, the vocabulary, and what it means, the math part is easy. Write down everything that is typed or written in this video, and be sure to pause this video at any time that you need to slow things down. Okay, remember, here's our vocabulary. A permutation is an arrangement or listing of objects in which order is important. Okay, so for example, let's say a whole bunch of people are running a race, okay, but there are only 3 spots for first, second, and third place. Well, I could get first place. You guys could get first place. Somebody else could get third place. I could get third place. You could get second place. I mean, the order can switch by who gets in first, second, and third. There are so many different options of people that could get first, second, and third. Let's say that there are 10 people running this race. 10 people have the option to get first. But once that first person gets it, now there are only 9 options to get second place. And when the second person crosses the finish line, now there are only 8 options left to get third place. So that's what permutations is. It's an arrangement or listing of objects in which the order becomes important, because only 10 people can get that first slot, only 9 people can get the second slot, and only 8 people can get the third. And then if we multiply all of those together, it tells us how many different choices there are for first, second, and third place. Easy as that, right? Once you get down the vocabulary and how to say permutations, again, like I said, the math is pretty easy. Here's an example in your book. You don't have to write this slide down, okay? It says Julia is scheduling her first 3 classes. Her choices are math, science, and language arts. Use the fundamental counting principle, which we already know from a previous lesson, to find the number of different ways Julia can schedule her first 3 classes. Well, she's got 3 choices for her first class, but once she's used one of those choices, for her second class, she only has 2 choices left. And then for her last class, she has 1 choice left. If you multiply all 3 of those numbers together, that tells you how many different options you have of first, second, and third class. Okay? So let's work on some examples with these. So we have 8 runners. Look at my runner coming in. Okay, so 8 runners are competing in a 100-meter sprint. In how many ways can the gold, silver, and bronze medals be awarded? Well, there are 3 different places: gold, silver, and bronze medals. There are 8 runners, so the first place, gold, there are 8 people that could get gold. Well, now we've taken one of the runners out. Let me just draw our runners here. I am an awful drawer, I will say. I am no artist at all. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so here are our 8 runners, right? Woo! Okay, so all 8 of these people have the option to get the gold, okay? But once somebody has gotten gold, they're crossed off the list. They can't get gold and silver. That's not fair, right? So that person that has gotten gold is now crossed off the list. So we only have 1, 2, 3, 4, 5, 6, 7 people who can get silver. Once that person has gotten silver, now we've gotten somebody who got gold and silver. So we have 1, 2, 3, 4, 5, 6 people left that can get that bronze medal. okay? To figure out how many choices we have, meaning this person can get gold, this person can get silver, this person could get bronze. Or this person could get gold, this person could get silver, this person could get bronze. Already, those were two options, right? Two choices for how many different choices we have here. There could be so many different ways that we could describe this. These three people in the middle could get gold, bronze, and silver, okay? Or any number of different ways. So many different ways that we could figure out how many different ways we have. By putting 8, 7, and 6 here, and then multiplying them together using the fundamental counting principle, 8 times 7 gives us 56, and then we need to multiply 56 times 6, not times 7. Then we need to multiply 56 times 6, and that's how many choices we have. So you can use your calculator. 56 times 6 gives us 336. So there are 336 options for people getting gold, silver, and bronze out of 8 runners. Okay, so let's move on to the next one. 5-digit locker combinations are assigned using the digits 1 through 9. In how many ways can the combinations be formed if no digit can be repeated? So we've got 1, 2, 3, 4, 5. Okay, we've got a 5-digit locker combination and 9 numbers. So 9, 8, 7, 6, 5. Okay? Then what you need to do is use the fundamental counting principle to multiply all of these numbers together. 9 times 8 gives us 72. Then we need to do 72 times 7 times 6 times 5. So 72 times 7 is 504 times 6 times 5. So there are 15,120 combinations that can be formed if no digit is repeated for this 5-digit locker combination. Okay, now, sometimes we will see permutations like this big P standing for permutation, right? And we've got 2 numbers inside the parentheses here. Our second number tells us how many options we have. So there are 4 options here, so I did 4 lines. Our first number tells us what number we start with. So that number is going to go here. Then, now if we can't have 7, now we go down to 6, then 5, then 4. And then we use the fundamental counting principle to multiply them all together. 7 times 6 is 42. Then we can do 42 times 5, and then multiply that times 4. So 42 times 5 gives us 210. And 210 times 4 gives us 840. So there are 840 options for this permutation. We're going to do a couple more examples like that. Okay, we've got 3. This number tells us how many spaces we need. And this 4 starts us off. So 4, 3, 2, and then multiply them together. 4 times 3 is 12, and 12 times 2 is 24. Last one. 5, this tells us how many spots we have. And this number starts us off. So 5, 4, 3, 2, 1. Multiply them all together. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And 120 times 1 is 120. So 120 options. Okay, that's all I have for you guys today. I hope you guys have a fantastic day, and I will see you tomorrow.